everyone, today we're going to go over the problem with a hollow sphere rolling down without slipping. We're going to find a translational acceleration of the sphere without knowing the radius or the distance that the sphere travel. So we're going to start with the free body diagrams here. So like I said, we don't know the radius, so we're going to name this radius of the sphere is r. And then the distance the sphere travel, we're going to name it distance x. So that's what make this height equal to x sine theta. And we know the moment of inertia of the hollow sphere is 2/3 mr squared, and velocity equal r omega. So there's many ways to approach these problems. We're going to solve this problem using conservation of energy. The reason why we can use that is because the ball rolling without slipping. So that'll tell us that the energy is conserved. The final energy and the initial energies is equal to each other. So at the beginning, the sphere only have the potential energy. It does not have kinetic energy because it's not rolling. It's at rest. So only potential energy available. So mgh. And then the final energy is make up of both translational and rotational kinetic energy, which is equal to one half mv squared plus 1/2 I omega squared. Now we have this equation with too many unknowns. We're gonna substitute everything in. We know the moment of inertia, and we know omega equal to v over r. So we're gonna substitute everything in and cancel the like term. So we have mass on both sides. Cancel the mass. We cancel this too. And the r squared as well. So we're going to cancel r squared. We are left with gh equal 1/2 v squared plus 1/3 v squared. So combine everything. We have gh equal 5/6 v squared. Solving for v squared, we have v squared equal 6/5 gh. And we know that h up here is equal to x sine theta. We can substitute that back in here as well. So v squared equal to 6/5 g times x sine theta. So we know this v. But the problem is asking us to solve for translational acceleration. So in order to solve for the acceleration, we're gonna use one of our kinematic equations. V squared equal to vi squared plus 2ax. X is the distance that the ball travels. So we know that the ball is at rest. So at the beginning, the velocity is equal to 0. So we're gonna substitute everything into this equation. We know v squared is equal to 6/5 gx sine theta, which equal to 2ax. And we can cancel the x since we have it on both sides. So the x is gone. We are left with 6/5 g sine theta equal to 2a. We're going to solve for a. A equal to 3/5 g sine theta. And substitute everything back into this equation. Now we have the translational acceleration is equal to 3.62 meters per second square.